Good morning, campers. Today we're going to be dealing with a particular subject on the old land yacht project relating to motor cooling. Now, as I mentioned in a previous video, unfortunately my timing being perfect as it generally is meant that I missed out on purchasing one of the XS Turbo's blowers. So I've been searching now for past couple of weeks to try to find some sort of an alternative or some sort of alternative means to supply a RPM independent airstream for cooling the monster 13-inch motor that's currently occupying the yacht. Now, what I've done is I've taken a kind of a two-stranded approach to this. I'm somewhat, I suppose, against some of these so-called electric supercharger products that you see sold around eBay and that, because just by the very nature of them they seem quite flimsy and not really suited to what I'm trying to do. But in the spirit of testing and trying things out, as opposed to creating ideas and thought processes out of thin air, I kind of decided I was going to have to test the theory. Now, my first approach that I took a few weeks ago, so I got myself a turbocharger from, guess what? A BMW 530D. Yes, the old 530D strikes again. This is a Garrett turbo. It's a GT2556V, and what we have here is the compressor side of the turbo. I've basically taken it apart, cleaned it up in a kind of a general fashion so that I'm not getting oil all over myself, and kind of did a bit of an autopsy on it to see what exactly that I could do to make this baby electric. So, a couple things here we got to understand first of all, before we can even look at this from a EV perspective, is what does a turbocharger do for a combustion engine? Well, what it does is it provides pressurized air into the induction system. Now, the emphasis here is on pressurized air. Any kind of a fan can provide airflow. It just moves air from one area to another against little or no resistance. Now, a turbocharger typically is comprised of two components. There's the exhaust gas turbine that turns a shaft by the flow of the exhaust gases past a turbine wheel, and then there's a compressor wheel, which is this guy, and the compressor wheel sits on the same shaft as the turbine wheel, and it gets spun up by the exhaust gas flow. And this wheel here, when it fits inside the compressor housing, like so, there's the back lid on it, and the shaft going in, basically becomes a rotary compressor. So what's the difference between a compressor and a fan? Well, a compressor creates pressure, and that pressure then creates flow, whereas a fan can't create pressure. So why are we talking about this? It's not as if I've got a 6-cylinder diesel down in the land yacht. Well, and this could be talking myself smart here, but here we go. I would actually prefer to have a blower that created pressure and fed that into the motor. as opposed to just moving airflow. Now, why would I make that distinction? Well, if I have a moving airflow and it encounters an obstruction, it's just going to stop, or it's just going to slow down. So, for example, a tight bend, restriction in a pipe, that sort of thing. Whereas if I have pressurized air, well, it'll just push its way through. So, yet to be determined whether this makes any difference at all, but we'll see. So, back to our Garrett turbocharger. So, as I said, I stripped it down, got rid of the exhaust gas turbine because we don't have exhaust gases, which is good. So we need a means to spin this compressor wheel. Now I know anyone that's worked with turbos and that kind of thing, or cars in general, will know that these like to spin very, very fast. Up over 100,000 RPM is not uncommon. And you need to get yourself a graph called the compressor map, and that basically maps the compressor wheel speed versus pressure. So we need a way to spin this guy very fast. Most small little DC permanent magnet motors usually spin maybe, and I mean maybe, up near 10,000 RPM. That wouldn't really, it'd create airflow, but any kind of an obstruction would just create back pressure for me. So we need to spin it faster. Fortunately, there's a reasonably easy solution to that, in the shape of brushless motors used in model aircraft, model cars, that sort of thing. So I went ahead and ordered a motor controller and some componentry for a brushless motor that's supposed to be able to spin up to near 40,000 RPM. Now, I'm pretty good with, you know, bits of general lathe work and so forth, but certainly not good enough to make shafts that can spin that fast. So I've got the motor with a engineering shop, and they're making me a shaft to be almost the same as this one, that will let me mount the compressor wheel onto the motor, mount the motor onto the back of the compressor housing, slot the whole thing back together, and have an electric turbocharger. So we'll see how that plays out. But in the meantime, kind of under a little bit of pressure to get the yacht sailing. So what I decided to do, take, as I said, a two-tier approach to this. So I noticed that EV West had a blower kit for sale, and I contacted them, and the guys tell me that they use 4 of these on their Pikes Peak M3, so that's certainly made me think a little bit more positively about that, and I went ahead and ordered one of them. And what you see is it here, obviously with my own bracket on top of it. Was specified to draw 4 amps at about 12 volts, and I've just verified that with a bench power supply. It does spin, it does create air flow, and a lot of it comes out here. So we'll bolt this onto the car and we'll see how it performs. It may well be that I've just wasted a load of cash on the Garrett turbocharger mod, and that this guy will work perfectly, but we'll see what actually happens. And the way I've designed the cooling band on the motor is that I can fit two blowers. The one thing though about this is that it does not create any kind of pressure. It's just flow. And what I mean by that is when I turn this on, I just put my hand, if I just hold my hand here, you get airflow blasting up through it, which is perfect. But if I cover the outflow, you don't feel any pressure on it. It just basically stops. It just can't create any pressure here to force air past the obstruction of my hand. Now again, we need to make a distinction here. There will be no obstruction to this airflow in the EV application, because the air simply comes out, goes through a tube, gets blasted in onto the commutator, and cools the rest of the motor before exiting. Now there is some restriction in there, because it's not quite a get out of jail free scenario, because the air will have to force its way down through the field coils, down through the length of the motor and out the exit. So what I'll be quite interested to see is just how much airflow there is coming out of the exit end, which is the drive end of the motor. This is where I think that a compressor application from the Garrett might be a little bit better, but we'll see. Certainly, if the application was a combustion engine of any sort, even a lawnmower, this would be completely useless for that, because it can create pressure. And the whole point of a supercharger or a turbocharger is to create pressurized air, so that you can compress the air, get more fuel in there, and you get more bang for your buck, basically. Our application is completely different, and yet strangely similar, in that the more air that we can force through the motor, the more power that we can force through it, hence the more bang for our buck. So different applications, and I think this will work pretty well. So what I'm going to do now is I'll just run this up on the bench. Unfortunately, the sound issue really won't translate too well onto camera, but we'll give it a try. Once we have it tested here, go down, bolt it on the yacht, and run it up there, and see if I haven't screwed up the bracket or something, and see if we can get it tubed in there. So let's power on and see what we get. So just got a benchtop power supply. Just going to set the current on it there, just for a high enough level, and we're on. I'm just going to start winding it up. So again, I've just got my mounting bracket on here. It's just comprised of a bit of pipe, a couple of pipe fittings, and a bit of angle steel welded on here. You'll see how this fits into the car when we're doing that part. So we'll start winding up. Now you can actually hear the motor starting to spin at about 1 volt, and there's pretty much no airflow there. Up to around 2.5 volts to 3 volts, we're actually detecting airflow there. Up to 3 volts exactly. There's 3 volts. You kind of got kind of airflow you'd get from one of those little pocket fans that they sell for cooling you down during the summer. So let's go up to 6 volts. There's 6 volts. There's quite a good airflow. Let's see if I can get a piece of paper or something here that might just demonstrate that a little bit better. So we can see there that we've got, it's definitely, even at 6 volts, there's a significant airflow there. Now I am reducing it down to a 50mm pipe as well to suit my particular system. So let's go up to 9 volts. Now it's making a good bit of a racket at this stage. There's 9 volts. And again, pretty impressive airflow. All the way up, probably out of the shot at this stage, but it's doing it. If we go up to about 12.5 in terms of the running, got some serious noise going on now, and it's serious amount of air. If I had any hair, this would be blowing it back. But if I do that, there's just no pressure there. There's very, very little pressure. It's only a fan. It's not a compressor. I don't know what would happen if I put that on it. Yeah, that's good to see. We're actually able to lift that off it, so we are getting, you know, we're getting a good flow there, but as soon as I actually push that to cover it, the force actually goes away. But as a fan, as you can see, we're good to go. Drawing now 12.5 volts, about 4.3 amps, and there we're off. So, stay with us folks, going to go down and bolt this thing into the yacht. Okay, we're down here at the yacht and going to see if we can get this blower installed. So, it's installed here using one of the Remok mounting bolts, which is quite handy because we get to avoid having to do any further drills. Just putting a little bit of tread lock on this bolt and we'll get it installed here and hopefully the whole damn thing will fit. So let's see what happens. That's kind of a good start. The old ratcheting spanner, very handy piece of kit. Yeah. There we go. No need to go too mad. There we are folks, one blower installed. Doesn't look too bad actually, not as good as the EV West version, but we've only got one of them. So let me get some tube organised and we'll start plumbing this thing in and see what happens. Stay with us. Okay, so we got the ducting just very roughly sitting in here. We kind of plotted a route for it that keeps it out of harm's way and doesn't take up too much space. So go through that shortly, but it's installed, coming around, and it'll be going into the far side air inlet. And I guess my theory is this might let me put another blower here and then bring the air back that way to go into this side. So see how that works out. Let's get this Jubilee clip tightened up here. It's a little bit on the tight side, so I'm probably going to make a complete muppet out of myself, as I generally do. Try to trap my finger in this as well because that would be rather sore. Come here. Pain in the granny. Here we go. Maybe done a little bit too far there. There we go. Okay, we need to go a bit tighter on that because the hose is, I think the hose is 2-inch, but the hose is 2-inch. The piece of pipe is 50 mil, so there's a slight difference. I should say not difference, distance. That should do it. So next thing I'm going to do then, put some power to this and just blow out any dust or debris that might be in that line, and make sure we've no air leaks and hook it up to the motor. So stand by. Okay, well the good news is I managed to blow all the dust out of that hose. The bad news is it's gone all over the place here, but that's life. Just rigged up some power to the wiring harness. It comes with its own fuse and relay, so that's quite helpful. It's got this silly micro switch on it here. Presumably that's for the throttle body to hit that when you go to full throttle for the boost to come in. Whatever that's supposed to do for you. So just turn the hose away. Yeah, we got air coming out of it. It's cold, there is that, but it's definitely flowing. But again, there's just no real force behind it, so just using my relay. Yeah, I can almost hear some little 1 litre petrol engine revving up onto the red line when some guy floors that thing. Anyway, I'm going to connect it up to the motor and yeah, see what happens. Okay folks, the blower is in, and that's one piece of good news. Second piece of good news is no one will ever mistake this for an electric car again, because it's got an induction roar that would make a V8 jealous. So apart from that, it's just wired in. I got rid of this nonsense. So we're just set up now so that when the ignition comes on and the car fires up, the blower kicks in. So ultimately we're going to need to run it with a temperature sensor or something like that, and a switch in the cabin. Clearly it'll have to be one of those guarded missile type switches with a big blower symbol on top of it. So I'm going to roll her back outside, crank up and listen to that roar. Alright then, let's fire this thing up, see if it works. Well, you got a pretty good idle. This thing is making noise, it's sucking and blowing. Let's see if the motor likes it. Mistake this thing for electric anyway. That'll keep the pedestrians from walking out in front of me if nothing else. Anyway folks, let me knock this down. Anyway, that's the blower installed, at least the first iteration of it. I doubt it'll be the last. So stay with us for some more blowing action. Thanks for watching.